calculation for C2 is generally done A times B times C2 plus empty running factor times C1. What are these things? A is the mass of the waste, B is the distance, C1 and C2 are basically carbon conversion factors. So you are getting these factors from your government sources, from published sources. So once again, if you don't have project data, you can average of the take from for the distance, you can take the average of two nearest processing or landfill sites. You can assume a rigid type of heavy goods vehicle, HGV, which a 50% load factor, and transport for on-site reuse is considered zero. So if you were to take this waste and use it on site for some other thing, maybe for the new asset, there is no transport emission. Okay, so using these basic principles, you can do calculations for C2. C3 is waste processing for reuse, recycling, or recovery. So now you have some material waste which is transported. Any emissions that come from processing of that waste up to its end of waste state is to be considered. So this applies to decontamination. So you may have to do paint, has to be stripped, mechanical processing, for example, crushing concrete to maybe reuse it as an aggregate somewhere else, or for fill, material separation and recovery, for example, steel bar. So if energy recovery is used, incineration should be done in the UK in R1 compliant plants. C3 includes any emissions that come from burning or incineration, fuel and equipment used in its preparation. If the incineration is not R1 rated, you should then report this in C4. Best thing to do is to look at your EPDs. EPDs may have C1, C2, C3, C4 information. If that is available, use that. That way, the number of calculations you have to do significantly goes down. Then for C4 disposal, the material that's not going to be used anywhere, this covers the impacts from final waste treatment of materials that cannot be recovered, landfilling or incineration without energy recovery. So this includes emissions from degradation, pre-treatment energy for sorting, shredding, those kinds of things. Now, the default UK 2024 factors per material type in kilograms carbon dioxide equivalent per ton. There is a fuller list provided in the RICS standard. For brick, concrete and bricks, you can assume 1.234 kilograms carbon dioxide equivalent per ton of wasted concrete or brick. Plasterboard is about 71.95 kilograms carbon dioxide equivalent per ton. Bio-based material and so on are all provided in our standard. This should be used basically in case there is no data for your project location. Otherwise, you should use national defaults or project-specific disposal scenarios. Then comes Module D. Module D is reported on, again under two separate submodules, D1 and D2. D1 is all potential benefits and loads. So maybe these are negative or positive from reuse, recycling, and energy recovery from the net output flow of materials existing in the system boundary or from other recoveries. So basically, this is outside of the system boundary, any emissions or benefits, so plus or minus, you may be having, let's say there is structural steel that can be sent to another site. So it's a benefit, not a load for this asset. So module D1 looks at those. Module D2 is the potential benefits and loads from exported utilities. D1 could be basically materials, products, systems, whereas D2 is essentially exported utilities through electric energy, thermal energy, or potable water. So for D1, which is reuse, recycling, and energy recovery, this submodule captures potential carbon benefits and burdens from materials leaving the system boundary at the end of life. So if you have a situation where you have steel, that steel is going to get reclaimed and reused somewhere, recycled. Reused somewhere. If you have a structural steel beam, that can be taken and used in some other project. So that's basically reusing. Recycling would be you don't use it for its original intended purposes. You then crush it and recycle it for some other lower level purpose. And then you also have energy recovery, in which when you incinerate timber or landfill gas recovery, it's basically related to those kinds of activities. Module D, if you do not include, it's fine, but you should try and include modules A, B, and C. Then you have your exported utilities. These are captures avoided emissions due to energy or other utilities exported from the asset. So if you have PV on site and you send out electricity to the grid, that should be considered in D2. Any heat recovery, any treated water or other flows. This would generally apply to infrastructure assets, such as wastewater treatment plants or energy plants. Buildings with net export and energy or utilities must be exported beyond the system boundary, not reused on site, to be counted under D2 exported facilities, so utilities. So basically, whatever is being done here is leaving your system boundary, your site. If it's not, then it cannot be treated here. Okay. So I think today you are going to be, you already sort of looked at Gabby, I believe, right? And IFC Edge. Today you had a session on BIM and CDE. We completed basically modules, all modules briefly touched upon, not gone into much detail, but we have looked at those. You will have a session on low carbon materials. I will now show you EC3. I think there is a session planned by IFC on financing decarbonization initiatives. Tomorrow, I'm going to be taking, I think, about 2 sessions in which I will cover advanced topics. So my plan, time permitting, is to talk about uncertainty modeling, data that's uncertain. How do you account for that in WLCA? The RICA standard provides a model using which you can incorporate uncertainty. We'll briefly talk about time value of carbon, like time value of money. I'll again touch upon biogenic carbon. We look at grid and material decarbonization. And time permitting, we'll look at AI and how it can help sustainability. So artificial intelligence, I think, is pretty much everywhere. I don't know how much you guys are using it. Most people these days start with ChatGPT rather than with Google search. So we'll briefly touch on that also. So let me stop sharing. Okay, should I move to EC3? Do you have any further questions? Anyone has any questions? Okay. If not, let me see if I can share my screen. Is it possible to share Microsoft Edge. Yes, it looks like I can. Okay. Okay. Let me know if you once you see my screen. Maybe a good idea to.
Yes, sir, your screen is visible.
Perfect. Thank you. Maybe I'll log out. So EC3, which I believe is embodied carbon in construction calculator, therefore EC cube or EC3. It's by an entity called Building Transparency. Building Transparency has been, I think, started at the University of Washington, Seattle, got a lot of support from the industry, including Microsoft, Amazon's, Skanska, some construction companies. And it was then, this has been launched. It's free to use. You need to have an account. You can actually use your Autodesk account or your Procore account. You can also use Google, Microsoft, Amazon, LinkedIn, because they have, Microsoft uses Microsoft as in Microsoft that produces data centers and other buildings. They use EC3 also. So you need to have your login and password ready, and you can then sign into EC3. Okay. This is the interface that you will receive, and it's pretty interesting, very simple to use. As the name suggests, it's embodied carbon in construction calculator EC3. They have a good coverage of India, so I think about uh, over 50,000 or 50 EPDs on this scale, I guess. In the US, obviously, there is a lot of information available, and so on. Okay, so lots of EPDs available. Concrete is probably the most. You have good number on steel, and as you can see, as we go into more complicated materials, plumbing is low. They're trying to increase that. Conveying equipment, I just saw very few EPDs. And then you can see things start to slow down when more MEP related components come into play. Okay. So let's begin using this tool. Can you all still see my screen? Okay, I'm going to do a little bit juggling here so that it's easier for me to manage. Okay, so what we are going to do is first, without even going into an assessment, you can use this tool to look for EPDs. So maybe you're doing a very simple WLCA in Excel, you need some EPDs, you can use EC3 to search for EPDs. Okay, so you can go, let's say concrete, ready mix concrete, and in this case I have already, so it'll start at global. You can say global, Asia, Southern Asia, and then click India, click OK. So now we are searching for concrete, ready mix concrete. Let's say we remove lightweight. We want to search for all EPDs for ready mix concrete in this jurisdiction. We are looking for any kind of EPD, product specific or industry EPD. Let's hit search and see if we can find any EPDs for ready mix concrete in India. Okay, it looks like we did. We found 12 EPDs. One is an industry EPD, and they are all from ACC. And so if I now want to get details on this particular EPD, I can click details. You can see the details, or you can click open. It'll take you to a new tab. And you can see ACC's M80 grade was issued in 2018. It's already expired, so technically you shouldn't be using it. It has a GWP reported value of a declared unit of 1 cubic meter. It is 476 kilograms of carbon dioxide equivalent. Now, because there is some sort of a mismatch in how this EPD has been developed, it says that it's going to add 10% to that GWP number to account for that discrepancy. So suddenly now your uncertainty adjusted GWP per declared unit of 1 cubic meter is 523.7 kilograms of carbon dioxide equivalent. Okay, and you will notice here that they do this only for A1, A2, A3. No other module is reported. This was developed as per this PCR. This is the website. So you will see that this is OpenEPD format. This is not PDF. That's the beauty of using EC3, because you get the data that you need in who was the verifier, who was the EPD operator. ThinkStep is the company that did the LCA, and so on and so forth. Okay, so you can now open this in JSON format. This is the OpenEPD format. So this is that machine readable format that I was talking to you about. So you can see all those pieces of information. It's M80. It's the impacts are GWP A1, A2, A3, 476 kilograms. So this is the JSON machine readable format. You can download it and do something with that, or you could just simply click on the PDF and you can download the PDF EPD. Okay, so it tells you how all these calculations are done. Okay, stop sharing. Cancel out of this. Close. And let's see, I think if I were to go in and say, look at industry EPD, there is one industry EPD, but that may be a Canadian, but so let's look at this one. Yeah, this is Canadian, so for some reason it has shown up here. That's incorrect. Cancel. Let's go back to finding materials. So this is the interface that you would be using. So let's see if we can find any masonry EPDs. I think AAC may be too tricky to find, but let's see. Maybe not. So let's look at bricks. It says global. We got to change that to Southern Asia and then India and then okay. Remove this and search. They found one EPD Hopefully that is from India. No, it's from UK. Um, I don't know why that's happening, but you can see some issues. It's English, BRE Global, done in the UK. So if that's the best brick EPD that you can find, so cancel out of that. Let's go back, look at perhaps steel. Maybe we'll have rebar, maybe better off here. Search. I'm going to remove the validity, go global, go to Asia, go to Southern Asia, go to India, click OK, search, nothing found. So it doesn't have that good a coverage. Okay, so let's try. I doubt we'll have for anything else. Let's see if we can find something. Industry PD, jurisdiction is South Asia, India. Yep, it found something, but it somehow, for some reason, bringing Canadian stuff. So maybe my search is not working, but the search feature is pretty straightforward. But maybe I need to log off, log on again, or some such thing. Yeah, so let's go back here. To see how to search, you basically go into find and compare materials, click on ready mix, click here and say search EPDs. When you go to this screen, there is this location or geography that you can set. You can click Asia, Southern Asia, India, okay, and remove it looks like they do not have any valid, currently valid EPDs, even on concrete. Okay, it's searching. Remove lightweight, research. Yep, so no valid EPDs for India. These were the same things that we saw earlier. There is some low emission. M15 grade is 177, M25 is 244, and you can see the emissions here. So that's how the interface for find and compare materials work. So we can click again, change this to Americas, North America, US, and you can go to perhaps Maryland, click OK, search. So for the US, it has found 1,511 product EPDs, 97 industry EPDs, and you can see in Maryland, close to Baltimore, Annapolis Junction, lots and lots of locations. So actually you could set your distance or search on a map and use the one that you feel is the best. So let's pick this one, click open. So this is the CPD. Very interesting thing you will notice here is that this is manufacturer specific, plant specific, product specific, and it's a LCIA match. So the uncertainty factor is really 9.5%, very low compared to what we saw in our other example. And the GWP for A1, A2, A3 is 337.4 kilograms carbon dioxide equivalent. Cancel that, maybe close it, and we go and close this. The real thing to do would be to actually do assessment for a building. Remember, I showed you day before yesterday, very simple Excel spreadsheet based Canadian embodied carbon standard. You can really do this here. So I had built this before, and click on baseline. So you will give the building name, project name, its purpose. So it can be educational, office, lodging, can be parking, residential, and so on. You'll provide the floor area, gross floor area, and so on. Done. You need to then provide a address, and you can do this using this Google map. So we provided this address. You can put a photo of your project if you want. You can add any project tags. They are blank here. Add any notes. It's basically, I did this many years ago. What stage of development you are in. So we are really in detailed design, or it could be construction docs. I have a construction estimate that I can use. For A5, I'll use a detailed estimate, and it's a new project, new construction. It uses concrete. There is no post-tension framing. Concrete is cast in place. There is no podium. We use concrete, shallow foundations, seismic category B, risk level I, low. And we are only going to do structures, the structure and the foundation. Okay. So that's the project description. And then it brings in this floor area. We are calculating A1, A3 only. And these are your summaries from that. But let's see. Remember, from that Excel-based example, we had foundations. We had those perimeter grade beams. We had pile caps, pilaster, and piles. So I brought all that information from Excel to here. The unit of measure is cubic meter. I did 21.4 cubic meter for this grade beam. And then I will basically go and look for the EPD for this. So I went in and I did a search. So now rather than going to that find and compare materials from your project itself, you can search for the right EPD. So in this case, since I know the address, I went and selected the EPD. Oops. I selected this EPD for this particular concrete. I got a product specific one, declared unit 1 cubic meter, because it is a product specific, meaning, remember, in the embodied carbon Canadian standard, the first assessment, baseline assessment you do is with the help of industry average EPD. So this, since this is an industry average EPD, it's not manufacturer or plant specific, it actually gives it a 1.2 uncertainty factor. So the A1, A2, A3 GWP per cubic meter is 310.7. Okay, so all this information is already there. Okay, so you will notice that for this line item, which was this perimeter grade beam GB1, That's the size. This is the concrete. I've already picked the right EPD. I've applied it. So it is already calculating the GWP for that beam. I do this for then all the foundations. Then I go to the shell, the structure, and perform the same thing, search for the right EPDs by grade. So 35 MPa would be different from 30 MPa, and you have 32 MPa and so on. Same thing you're going to do with structure, and you will calculate your realized calculated GWP from these EPDs. If there's anything else, you can capture it under others. You will notice that I'm currently using Uniformat, which is similar to Uniclass classification system, but on the fly, you can change the classification system to what's used in the US called master format. In master format, you're discipline based. So it says concrete, cast in place concrete, all of them are together. Okay. So on the fly, you can go back. You then have Uniformat in which it is elemental. Now you're looking at substructure, structure, grade beams, and so on. Okay. Now let's assume that this is done, right? So I can then click on charts. I can do a Sankey chart, GWP Sankey, in which you can see that ready mix concrete is basically doing it for concrete only. So it's showing you. This one is probably not that meaningful because we don't have that much data, but you can automatically create a Sankey diagram. You can look at a lead, something that you will submit to lead. That chart. You can do a GWP tree map, which is essentially telling you that shell is 79% and substructure is 21%, and it's all concrete. You can also produce reports. Okay, save them. You can do a Excel export of the quantity summary. Open that here. So you can see that it has exported this. Again, since we don't have much information in our project, we only have few concrete items, but it still exported that. You can also export a building elements Excel. So share window. So it basically will then share by element under Uniformat 2, substructure foundation type of element, material EPD used, quantity unit, master format classification, and the reference line kilograms per carbon dioxide equivalent, a conservative estimate, a realized estimate, and achievable target. So it basically provides you with all this information using the Carbon Leadership Forum's baselines. Okay, so that is done automatically. Close. And there are other reports also. Remember, we talked about ICMS yesterday. You will see that I have ICMS reporting also. So I can click Excel. Again, since we don't have that much information, it may not give you all that you need, but let's see, present something else, window, Excel, share. Okay, so it did produce something, but the data didn't get copied. Okay, copied from L3 tab, do not edit. Something went wrong. I guess they should have filled this. Oh, there is, yeah. So it has ICMS, have to double click that field. So carbon emissions per category, because we only have done A1, A2, A3, those are called construction carbon emissions, and that's 65.3. Then you can do by groups. These are the ICMS groups. You can see these are the ICMS groups, and it has given you for each group. That's pretty much it. So that would be the ICMS report. And you can produce other kinds of reports also. Okay. Now, you can compare this baseline with the reduced. So I did two separate projects, one with baseline in which I used the industry-wide EPDs, did the calculations. Then I did product-specific, plant-specific EPDs and redid the whole thing and saved it as reduced. I click reduce. It will then show you what changes or improvements we were able to accomplish. Okay. So basically from 65.3, we came down to 61.2. It's comparing A1, A2, A3 here. So you can see that the same calculations that we did in Excel can be replicated here. Okay. So I'm going to close this. Cancel this. And then what I want to do is maybe show you an example. EC3 has already built up examples. So you can click on all buildings. And then you can look at EC3 example buildings. Maybe look at single family residential projects. Oops, sorry. Good point. So where did we miss? Share. Can you see it now? Okay. So under plan and compare buildings, you can go to public buildings. So these are examples that they have shared. Under that, look for EC3 example buildings. Under that, look for single family residential, or you can look for any of these. I'm going to pick single family residential, a house in Texas. Click that, and it's going to open the project. Yeah. So it's a residential building, residential detached. It was done in 21. This is the address. There are no project tags, no notes. It's the stage at which this assessment is being done is 350, which is where construction documentation is being produced. Notice that I cannot change anything because it's owned by somebody else. I can make a copy of it and then adjust it to my needs. We have a construction estimate that we're going to use. It's a new project. Let's see if they've given any operational. So they have given some operational energy intensity factors also, and then so that you can get operational carbon also. They've given a floor area, and they are doing A1, A3 calculations. It's available in uniformat. So if you click here, it has substructure, which has foundations and basement construction. If you click on foundations, You can see that they are using aggregate perhaps to on a slab on grade, below the slab on grade perhaps, for which they have picked an EPD. So I should not do this. They picked this EPD, which is product specific, and it gives so these are all the EPDs available to them, and they are in California. So maybe we need to do US, Texas, click. Hmm. Okay, let me set the location again. Americas, North America, US, Texas. Okay, search again. Let's see if it finds anything. Maybe there are no EPDs for aggregates. Yep, there are none. So you have to find some other way of entering this information. Then you have ReadyMix 1. And for that, they may have an EPD. Yep, they have EPDs available. And they're using one particular EPD that they have found. Search industry EPDs. So these are all the options available to you. You can select this industry EPD. If you click here, it's going to apply to your project. But since I'm just viewing this, we have to use the one that they have already selected. So process remains the same. You go element by element. You see what kind of element it is. It uses ready-mix concrete. We go find the EPD, we apply the EPD, and it will automatically calculate the GWP by multiplying the quantity if the declared unit matches. So this is all of your substructure. Then you have your shell, which has the superstructure. It has some sort of a hot rolled section, 3 sections, and then some composite lumber. So maybe they have wall panels or timber or trusses and some steel. The exterior enclosure is basically made of all plywood, OSB sheathing, you have siding, and so on. Superstructure is done, roofing, and then they have some framing lumber, which is wood framing of 9 different types, provided in cubic meters, all of its GWP calculations done. So once the project is done, you click here, you can look at the Sankey chart now, which is going to be, Sankey diagram will be much more meaningful now. So you can basically see that a big chunk of ready-mix concrete is in basement construction, and it's categorized as substructure, and it sits here. So this is that Sankey diagram. It has everything from carpet, gypsum, steel, and those things. You can see the GWP tree map, which will tell you the hot heat map. Shell of the building has 44% of GWP. 36% comes from substructure, 18 for interior, and so on. You can again get reports. Okay, let's say leave. Yeah, I cannot work on that project because it's a public project. It's an example project. So public building, let's go back, use that as an example. Let's say my substructure has a foundation, and I can basically add a new item. It's called building element 4. Let's call it strip footing using 30 MPa. The quantity is 12 cubic meters. And now I need to search for an EPD for this. So I click on category, click on concrete, click on ready mix concrete, look for EPDs, set the location, Americas, North America, Canada, British Columbia, click OK, and then search. It has found several EPDs, which are actually product EPDs. These are all downtown. So let's look for North Vancouver, where this project is. Wow. So many EPDs from. So maybe we can sort by manufacturer. Maybe Heidelberg. Okay, come on. Okay, it found all the Heidelberg. Oops. It's very slow. Heidelberg materials. Click here. North Vancouver. I found the one that I was looking for. It's 5,800 PSI. Let's open it. So if that's the EPD I'm looking for, that's 32 MPa. I check, is this the one that I want? I can go back. And I can, okay, it canceled me out from there. So yeah, here, I think I picked this one. I will select this and say, use this collection, and it applies that Heidelberg EPD for me. And it automatically calculates the GWP. And if I want to go back and see which particular EPD I applied to this one, I can see it here. Okay, so it's a pretty straightforward process. You will search for the category, look for the location, search the right EPD, and say, use this collection. It brings and applies it here. And you can continue to do this. I'm only doing it for concrete, but you can do it for rebar, you can do it for structural steel, paint, floor, tiles, and most of the materials that are going to be used in constructing this building. So that's hopefully a useful tour of the overall system. I'm going to stop sharing and see if anyone has any questions. Okay, any questions?
So there are some questions in the chat of this
In
meeting.
the chat, okay, let's go there. Sir, how is this uncertainty factor calculated? That's a brilliant question. I think the best thing for me to do would be to go back into EC3, share. Okay, so you guys can see it. I'm going to open that EPD again. And so basically, this is how they calculate the uncertainty. So they look for all EPDs in that region. They look for the CLF baseline and see where this EPD falls. Okay. Based on that, they have a mechanism by which, so let's open this one. So they do this box plot and compare it to the EC3 baseline, the CLF baseline, where this particular EPD falls. And based on that, they say that this should be an uncertainty factor of 9.5% because they have good confidence about this EPD. So to look at the methodology, you can click here, they explain how the uncertainty is calculated. So basically, they look for range of GWPs for similar concrete, for example, and then they look for one standard deviation, look for the reported value, and see where it falls based on which they calculate. So you can see they're calculating 331.7, which is approximately 9.5% uncertainty. So that's, you'll have to read this in detail to figure out how they have done this uncertainty modeling. But I'm going to go over this tomorrow for the whole building. Right now, we're looking at every material and uncertainty there, but we can do it at the building level also. So EC3, there are quite a few. I'm sure you guys have looked at one click LCA. There is something called e-tools. These are two major construction sector related LCA tools. I think one-click LCA is available in India. I'm sure e-tools is. These are web-based tools. Then there are some specific ones like we have perhaps if you go, you will have something called life cycle evaluator. Then there is one that is just released. It's called Sterling. But these are more comparable to EC3. Though one-click LCA and e-tools are complete LCA, so they can do all modules, they can do buildings and infrastructure, whereas the rest of them are primarily embodied carbon calculators. So they look at modules A1, A2, A3, A4, A5 only. Okay, looks like there is a question. Go ahead, please. You can use it for any type of concrete for which the EPD is available. So if you, like I picked Heidelberg, the Heidelberg concrete is, they have some admixtures and some other types of concrete which are low carbon. So it can be, point is the EPD for any material, if it exists in EC3, you can use it. It could be conventional concrete or it can be low carbon.
So there is one more question from Mr. Abhiram.
It is a Tracy by default, yes. Abhiram, that's if that's the question.
Sir, I have a question.
Yes.
In EC3, we saw that there are very few data available for India. So if I am doing something for India and I am selecting the EPDs which are available in EC3, do I need to apply some more correction factors on that?
I'm trying to see if I can increase the volume. I'm not able to hear you. Give me 1 minute. Can you repeat the question? I'm sorry.
Yes, sir. I want to ask that there are very few EPDs available for
Mhm,
Indian scenario or the geographical location. So if
mhm,
I am taking the EPDs available in EC3 as a reference for my case study, which is based in India, do I
mhm.
need to apply some correction factor on that or I can use them as it is?
So technically, you shouldn't be using EPDs from another country, but as you saw, it's such a very low volume EPDs available. But this is what I would do. I would go search for EPDs outside of EC3. Okay, so first go look for EPDs for the Indian scenario. As we saw yesterday, there are EPDs outside of the EC3 system. Once you find these, let's see if I can show you. Go here, click here. Share. See if you can see it. So I'm here. Let's close out the project. Cancel. Are you sure? Yeah, leave. So what you can do is you can add an EPD of your own from of particular file. So let's say EPD India RMC status entered manually, uploaded, import EPD from PDF, upload EPDs. I think I shared with you guys um, an EPD. So let's see, continue, uploaded, done. So now you have uploaded this PDF, it will process it and it will become available to you in your import. So I have this EPD. Let's see, find materials, category ready mix. Program operator was, I think step. So basically, the point I'm trying to make is if you find EPDs outside of EC3, you can bring them, import them, and make it available for your own projects.
Right. Thank you, sir.
Okay. More questions? That's it, or you have more questions? How much more time do we have?
Yes, sir. The scheduled time was 11:45 by this. So we can stop the session now.
Okay, I think there's one question that I just saw. Okay, sir, is embodied carbon different from? Yes, embodied carbon is different from operational carbon. Embodied carbon emissions are related to product manufacture. Operational carbon emissions are related to the energy use, water use in a building or an infrastructure asset. So yes, they are completely different. You will see in my notes, in the slides, I have spent a lot of time defining. I think first day itself, we defined what is embodied carbon, what is operational carbon, and so on. Okay. For attaining which is required to be assessed. You should be doing whole life carbon. You should do both embodied and operational. All right. I think we'll probably close now.
Yes, yes.
Who's doing the next session?
Sir, I will be taking a session on
Okay.
Yes.
Perfect. Okay. And then I think we have a session on circularity. And is Atif coming back at 3:45?
Yes, 3:45 we will have a session from IFCH.
Okay. Perfect. Okay. So I will let you guys continue. I hope you have a wonderful day. I will